I at the outset would like to thank the Advances 23 team to invite me here, especially Jai Krishnan sir for all the efforts to get me here. Thank you so much, and it's a very interesting topic, troubleshooting in IVF. We've always been doing it on a daily basis. Those who work in the lab, we know that we are doing it on a daily basis. But just the first thing that we need to always look at is there are mistakes that happen in the lab. It may be very small to quite a significant one, but we just have to keep looking out for it and prevent it at as much as possible. As we always say, the first step to finding a remedy is to accepting a problem. So once we know that there is some issue in my lab, that something is not functioning fine, we start looking out for ways and means to correct it. Let us say we all do our monthly meetings. We say, okay, for the month of April, my FET results has not been good. Okay, for the month of April, it's little early in May. So let's say for the month of March, my FET results has not been good. So then we go back and see what's happening. There are various instances. It can be as big as that, or when embryologist feels that the temperature on my stage is not working fine. I'm having a lot of fragmentation. Is there something that has got to do with this temperature? Or it could be that you're not able to find your cryolock. You have the patient there, Jai Krishnan sir has already posted for FET, and the cryolock is not to be found on that particular day. I'm sure that is one of the most sinking feelings we ever have in the IVF lab. Or there can be situations like, I'm sure embryologists seen, like, you have like prepared for 10 eggs a patient. That is what was seen on the follicular monitoring. But suddenly you have 20, 30 eggs per patient. The point is we need to have things ready for us to use for the patient. So in that case, there are various scenarios that you can look out in the IVF lab that, you need to troubleshoot on a daily day and also look out for the future. So you can have incubators not functioning fine, sometimes even off. So when we are looking at IVF as a process in the laboratory, it can be oversimplified down to certain important steps, such as what we require for the gamete and what is it in contact with, such as the consumables that we are using and the cultured media that we are using, because we don't put a finger into it. So, but it's a cultured media and the consumables that are in direct contact with it, the lab environment in which the embryos and the gametes are cultured, the culture system in large, just not what is there in the incubator, but is what is there outside of it as well, such as the laboratory air, to what is it that we have on the temperature, CO2, humidity, everything, VOCs, everything included, and the lab processes, what we have from the pickup, the selection, the ICSI, the IVF and transfers, freezing, everything included, the processes that we have. So it can be, the entire process does play a part in it, and each of these processes that we have broken down needs to be assessed when we are looking at troubleshooting. So when we are looking at errors in the IVF lab, is troubleshooting only to say, I want to improve my results? No. We have two aspects of it. One is we don't want to have errors, and if there are errors, to put in place a system that we avoid errors. Two, and continuously improve ourselves to have optimal pregnancy rates. Both needs to be done. So let us just accept that there are labs. I mean, every lab has got its issues and there are errors that happen. And what is it? It is just any failure on part to have a process as planned or as intended in itself is called an error in IVF lab. And every time we make even the smallest deviation from the accepted standard operating procedures, we do make a note of it in our master note so that we know what is the effect of it. Sometimes there has been issues where, the deviation that we have made has given us better results, and hence we continue to make the deviation, which in turn gets incorporated in the SOP as the standard protocols. There are two types of errors that we can have. The active errors, which are unsafe acts that cause immediate harm to the patient or the system, or the latent errors, which are like arise due to system insufficiencies. When we want to have, when we want to avoid the errors and to improve our system, we need to have a collective total quality management system. It all falls into one particular big umbrella called this. Whenever we have a talk on TQM, it sounds so boring, but it is something we are doing on a daily basis. So the introduction of quality system in ART is the concept for optimizing patient care, the quality of care for both the gametes and embryos, and the treatment efficiency, the welfare of the offspring also, and minimizing the financial burden on the patients and also on the center to achieve the desired outcome. We don't want to do elaborate things which has a huge financial burden both for the patient or for the center for a very minimal outcome. So this is something that it encompasses from the start to the finish. And we know that Mortimer has been one of the most front runners in ensuring total quality management in IVF labs. Both he has defined QC and QA for both. QC and QA is important. QC is what we are doing on a daily basis. QA is what we look at for the future so that we don't have issues. When we're looking at TQM, we have three important aspects that we need to do. One is process mapping. Whatever we are doing in the IVF lab, including the making of the dishes, as you know, who are all involved in preparing the SOPs, we have pictures, we have a description, and we have a picture of how a dish must be kept. How, when a process is, when from pickup to the transfer to the ICSI, how the process is mapped. At the same way, if there is a problem in this process as well, there is a way that you go through the process and then find where there's been a lack. And there has to be a process control, if at any moment there is a procedural deviation, the standard operation has to be checked into. And then, of course, the benchmarking. Every lab has a benchmarking. There are KPIs that has been determined by the experts. Of course, there are very little evidence or based on which those KPIs have arrived. But yes, we do have KPIs set by the experts, but we also have individual KPIs based on the set of patients that we cater to. We cannot, for example, expect a 60 to 70% blast relation rate when a lab is catering probably to the age of 39 and 42 maximum. So in that way you will bring down and say, okay, for the age of, when I'm dealing with a lot of patients with advanced maternal age, then my fertilization to pregnancy, this is what I expect. We need to have optimal and realistic expectations of KPIs as well, depending on the patient. And that is why a stratification of KPIs in terms of the age of the patient to the disease of the patient will help us in particular, which is not per se given in that publication that pointed to the KPIs. When there is a problem, okay, now that I have a problem, my FED results have not been good since February and March. So you need to see what is the root cause analysis. So in that, it is not possible to say one particular thing. For example, people who are working in the IVF lab would know, we will look at all the processes, map all the processes again, ensure that we're going through the same. We wouldn't change much, but sometimes the results automatically starts coming in. Sometimes we change from everything, media, CO2, triple gas, the culture media, the water that we use, the oil that we use, the consumables, everything we change one at a time to ensure that we know where the problem was, but still nothing happens. But then we say, at the end of it, sometimes suddenly something happens and our results might become much better. But sometimes we have found one particular problem, a specific problem. Sometimes we all know the incident of the culture oil which had resulted in poor pregnancy rates. So in that case, so there was a batch which did lead to it, for example, it is open and everybody knew about that, so that particular one. So for example, like that, there are specifics that will help us, and there are non-specifics which will help us as well, but we need to have a systematic investigative tool for for evaluating the risk, which is usually carried out, after that there has been an error. Error here does not mean just a mistake by the embryologist. Error here means a change in the system, or you see a difference in the results, or the results not just in terms of pregnancy rates, in the morphology or the quality of the embryos as well. So, problems anywhere, everywhere. That's exactly how we look at. We just don't, once I say that, let's say my embryo, my blast creation rates has dropped from 60 to 70% to 40%, I need to not just look at the culture system alone. We need to start right from the patient. What was the age of the patient? What was the disease of the patient? What was the gonadotrophin that was given? Was the batch? What is the batch of the gonadotrophin that was given? Who gave the gonadotrophins? Was the cold chain fine? So to what was the culture media that was given to me? What was the batch of the culture media? To oil, the consumables, to the processes, the CO2, the triple gas, to the water that I used, everything needs to be analyzed until the last stage. So when it comes to avoiding such problems, we start again with the patients. When we have a thorough system in place in every lab for every patient, then the problems are definitely reduced. So first, we need to have the details of the patient in the lab. That is the first thing. We need to know whom we are doing for what, and what are the processes that the clinician has discussed with the patient, and what is it that the lab is supposed to be prepared for. This must not come on the day of the pickup. It has to come at least 3-4 days before the pickup, so we know that on the day of HCG at least, that we know that we are supposed to prepare the lab for this particular patient. Of course, when every patient comes in, these are all the steps at which we do the double witnessing. Either you do it physically or you have an electronic witnessing. Both can happen. Of course, electronic witnessing has shown to have much less errors than physical witnessing, but it must be done at all these clear steps. So essentially, which means you need to have at least 2 people working in the lab at all points of time. The IVF lab should not be manned just by 1 person. You need to have at least 2. If one of your junior embryologists is not available at that point of time, or the second person is not there, you have to call a nurse, a senior nurse who knows the patient, and say, okay, I'm looking at Sangeeta's dish today. Are you looking at the Sangeeta again? So each step and the date and the step that is marked on the dish has to be double-checked, it has to be cross-checked by another person at all points of time. And there's always a sheet for the patients. For example, when there are labs which are dealing with a lot of patients on the same day, you can miss certain processes on that particular day. So there is a patient sheet for every patient which has to be looked at tomorrow. It's not looked at in the morning. Always it's planned the previous day. So these are all the things I need to do for these patients tomorrow, and it is always noted for that particular lab. So you go from -1, which is the day we prepare the dishes, to I take it until day 7, because I have a habit of culturing all embryos to day 7, unless otherwise there are none left after day 5. So it goes until day 7, until the day you culture. All these things definitely is there for every patient. Of course, looking at the culture conditions and doing it and analyzing it every day is the basic job of all embryologists. And we look at, as we know, the effect of stress is the max at the stage of the oocyte, and it is definitely lesser at the stage of the blastocyst. So we need to check all these things: temperature, pH, air quality, humidity, carbon dioxide, O2, and the VOCs has to be checked on a daily basis in every lab. And you have sheets for each as well. So we always have a list of things that we need to do: opening list, closing list, and the things that needs to be done in between. So ensuring that there are trash cans. It starts with that. So we can't have, as we know, we have to separate trash in different things. So from there, our work starts, ensuring. So embryologists come at least an hour and a half before the process starts. And we start with, okay, do I have trash cans? Do I have the enough material? All the materials are done the day before. Just that morning, in making sure that we have the trash cans, to performing the QC, that is checking the temperature and all that stuff. keeping the sheets ready for that particular days, and checking the gas that morning. The gas has to be checked at least an hour before, ensuring that there's enough gas for that particular day and the day after. Have we got this triple gas switched if need be? And then, of course, you go to the QC. Each incubator needs to have a sheet like this pinned to it at all points of time, so that every month you do it on a daily basis and it is there for each incubator. And for each, this is for the temperature. For each surface, you can have the temperature for everything, from your laminar airflow to your workstation to the ICSI station to everything. And then each incubator needs to have this sheet on that. That's mandatory. So you know where there is a deviation. Sometimes it will also tell you at what CO2 levels your incubator seems to function the best. It does give you a clue on that. Cryo tanks, each cryo tank also needs to have a paper like this, so that you know when you don't want to have things that happened in the US some time ago. So it is mandatory that, yes, you can have, if the automatic checking instrument equipment is there, that's fine. But still, even then, I know labs which have that goes in and does the physical check at least twice or thrice a week, and to ensure that it is there. We just don't rely only on the machines. We do go back and check it physically, everything as well. Of course, at the end of the day, when your lab all work is done, you need to have a closing checklist as well. So to wiping, to keep things in order, and to prepare for the next day, to clearing the bins, has everything been done? It also has to be checked on a daily basis. So everything, when we do all these things on a regular basis, and ensure that the processes that needs to be done for handling of gametes and the embryos is as per the standard operating procedures that has been fixed for your lab, then the chance of errors definitely goes down. And when you have this, if you have an error later, like you find out an error later, such as your pregnancy rate has been low, you have something to go back to and check where there has been a mistake. When you don't have anything on paper or anything on the system, how will you go back and check where things could have gone wrong? It is important, and now we know, and especially by the ART law, the QC is very important. They have mentioned about the QC and QA as well. So now they may not be strict, but in future, we might have to have all these things for our labs. We pray that it all doesn't become automated, which means our investment becomes huge, but that electronic witnessing does seem the way to go at some point of time. May not be now, but may later. For labs which are always looking at how do I manage these things, it is very simple. Have a junior person, doesn't have to be a junior embryologist, some person technology who knows the technology and understands the biology. They can do all this stuff, especially maybe not the dish preparation, but other things can be done by a lot of other people. You have to allot work accordingly. You can't just do everything yourself. That's the whole point of it. So when there is a problem, the first thing is to accept there's a problem and say, okay, I have an ethical obligation to look at it, and then address it and find a solution to it. That's the whole thing. And you should promote a culture in which your junior embryologists or the andrology technicians, they don't feel bad about coming and telling you if there has been a mistake made by them, and that is the best culture you need to have. They shouldn't be afraid of coming and telling it to you. Whenever they do it, you just have to say how to avoid it the next time, that they never do it the next time. That's the whole point of doing this. And yes, it is, when there is our patients involved in this, it is, it's very difficult to accept. For example, you've dropped the dish, or you don't find the cryolog, or, sometimes transfer the wrong embryos or use the wrong semen. It is very important to address it to ourselves and address it to the patient. Yes, it has got a reputation, our reputation at stake, and legal problems at hand. But yes, it is something that we need to be always looking at. Like I said, we don't have to bury like the man before. We can bury like the ostrich, because the ostrich is not burying to hide away from the errors. It is actually doing something below. It is just turning these eggs to make it better. So we could bury our head and say, I am going to do things in a better way when I find an error. So their errors will be there, but we just should not ignore them. We can use them to improve ourselves. And safety is always a priority. When you have safety and standards in check, quality automatically follows. Thank you so much for this opportunity.